Imagine spending 6 figures on an industrial 3D printer and then being told that you can only use the materials the manufacturer sells you. No alternatives, no flexibility, just their catalog, their prices, their roadmap. So that's the reality for a lot of production teams today, and it's exactly the problem HP is trying to solve. HP has been in the additive manufacturing game since 2016. And if you follow the industry, you know them for multi-jet fusion. That's been their focus, and for good reason. MJF became a benchmark for production-grade power-to-bed fusion. They've been developing that ecosystem ever since. Most recently with a new, smaller and more accessible MJF system that rounds up the lineup at the lower end. With that chapter feeling more complete, HP is now turning serious attention to FFF. And this is what that looks like. This is a HP Industrial Filament 3D printer 600 high temperature solution, released in early 2026, and it's built for one specific kind of customer, the engineer who's been hitting walls. Wars on material choice, wars on process temperature, wars on what they can actually make. Let's start with what this machine physically is. It's a large FFF system. 380 by 380 by 420 millimeters of build volume, standing 2 meters tall. It's designed for the factory floor, not the engineering office. And where it separates itself from most FFF machines on the market comes down to 3 things. Heat. The 600 HD runs a modular nozzle system. 280 degrees Celsius for your standard engineering grade materials like ABS, 360 degrees C for PEI, and up to 500 degrees C for PEEK and PAEK. The build chamber itself reaches 195 degrees C. These aren't numbers you see on most FFF systems. This is the kind of thermal performance you need when you're making parts for aerospace, oil and gas, or high-performance motorsport. Real end-use parts, not just prototypes. Openness. HP ships this with their own validated material lineup. PEK, PEKCF, PACF, PC, ABS, and more. But unlike some of the big names in this space, they're not locking you to it. The platform is open. You can qualify and run third-party materials. For teams that need specific certifications, exotic formulations, or just want to control their material costs, that's a fundamentally different value proposition. Process control. This runs on 3D Gens Slicer 4.0 and 3D Gens Connect, with full traceability built into the workflow. In industries where quality assurance isn't optional, that matters. Real-world proof? AGA Tracing has used HP's AM ecosystem to push past the technological limits of what their car components could be. Bioserve Space Technologies brought HP into a NASA stem cell research project. These aren't marketing case studies designed to sell a machine. They are validation that the system performs when the stakes are real. Who is this actually for? It's for production teams in aerospace, mobility, tooling, and industrial manufacturing who need high-temperature FDM and can't afford or don't want to be tied to a single material supplier. If you keep running into material limitations, this is worth a serious look. And it comes with the added weight of their industrial heritage and global support infrastructure behind it. The skeptic in me would say HP is making a big bet on FFF. The realist in me says they've watched the market long enough to know exactly what was missing. For more information and to get in touch with HP, we've put a web page together. Hit the link in the card right now. This was your 3D snapshot of the HP Industrial Filament 600 HD. HP's first move into FFF. And given what they've built with MJF, it's not one to dismiss lightly. See you soon for more 3D printing overviews, and until then, happy printing!